Chapter 9, Section 3, Reactions in Aqueous Solutions. So an aqueous solution, what is it? It's when a substance is dissolved in water. So you call it an aqueous solution, okay? And that's whenever you see an AQ, that's what it's referring to as an aqueous solution. Solubility, you'll hear this term often. You've probably already heard it.
Should have.
But solubility refers to the ability of a substance to be dissolved in another substance. So you'll hear terms like solutes and solvents. Okay, that all relates to solubility. You have to determine the state of matter for each molecule or compound in a chemical equation. So we've been giving you examples throughout all of these videos where we have the little s representing a solid or the little g representing a gas. Now you are responsible for figuring those out.
Can be done.
Okay, solubility rules. These are on the back of your cheat sheets, and on your cheat sheet you'll be able to read them. You probably can't read them now, but this is exactly what they look like. So when you have a compound, you are going to look at what is it made of and then where does it fall in these rules. Is it soluble, which is that top part here, like all these guys, or is it insoluble here? The only thing you have to keep in mind are that there are exceptions. So for the halide ions, these, if it's paired with silver or mercury or lead, then it's insoluble. If you have a sulfate ion, these are insoluble down here, whereas the rest are soluble.
Okay.
And then carbonate, chromate, these are insoluble except for these guys. Okay, so let's say you have lithium chloride. Well, you have lithium, that means it's soluble. Check the other one. It's a halide. These are soluble too. Check your exceptions. It's not there. So lithium chloride would be aqueous.
Okay.
Okay?
If it's not aqueous, they're going to follow it with an S for solid.
Yes.
Because it's insoluble and it'll still be a solid.
And so when you get a precipitate, precipitates are solids. Okay. So dissociation, pure substances and molecular compounds, except for acids, will not ionize in water or break apart. Water is a polar molecule. It's going to pull apart your ions. So the positives are going to be attracted to the negative charge of water, and the negatives will be attracted to the positive charge of water. So the ionic compounds are going to dissociate into ions when they're dissolved in water, but not your covalent compounds.
Okay.
Okay? Called covalent molecules if we're correct. Okay, let's get a pointer here. Let's go over some examples. So if you have NaCl, it's going to dissociate into its ions. So the first ion,
Na plus. So we're bringing it down into its charges. So +1, plus.
Do we have to write?
Got to write the plus to separate the AQ.
Yes. Right?
Yes.
Okay.
And then the plus, and then the Cl is going to break into its charge of 1 minus. And it'll still be aqueous as well. So what we're saying is if we take salt and we dump it into water, you are actually going to have the sodium ions and the chlorine ions floating around in the solution. That's what the solubility is. It's going to break apart. You're not going to see the salt at the very bottom. You're going to have the sodium and the chlorine broken apart, floating around as certain ions throughout.
That's why it's a homogeneous solution, because now you're not going to see two separate things. You're going to have all these ions floating around that you can't see.
Okay.
Okay, let's look at calcium hydroxide. So calcium,
2 plus.
and that would be aqueous.
And it's going to join with the hydroxide, which is an OH minus.
Okay, and if we're going to balance, we've only got 1 calcium, but how many hydroxides do we have?
2. Because of the subscript 2 on the other side.
Right here.
Means that inside this, for every calcium hydroxide that we are going to disassociate in that water, we're going to get the 1 calcium and the 2 ions of the hydroxide floating around as well.
Okay. So let's talk about, now we've got, I don't know, some different sections dealing with different reactions. So aqueous reactions that form precipitates. So precipitates, like we said, are the solids that form in a reaction, and they're insoluble in solution. So you're going to represent it with a little s after. Okay, and these are going to form in double replacement reactions. So double replacement, remember your positive charges, they're going to switch places.
Okay.
So let's look at
I
the
like these.
first example.
All right, so we're going to
Mhm.
switch Ag and Na.
Okay.
Switch spots. So it's going to be.
Let's start with sodium.
All right.
Okay.
So sodium nitride, or nitrate, sorry.
Sodium is a positive 1 and nitrate is a negative 1. Is this aqueous?
We're going to look on our cheat sheet.
Look
We're
at
gonna
the
look
solubility
at the back
rules.
And we're going to find our sodium. The sodium says soluble. We're going to find the nitrates. Nitrates are also soluble. So that one is going to stay as AQ.
Okay, now we've got silver and we've got chlorine that needs a pair. Silver is a +1. Chlorine is a -1, so it's just AgCl.
And
Now,
that's on the exception rule for
let's
the
look.
halide.
Yeah, number 4 on your solubility rules, silver X is insoluble. So that's going to form or precipitate your solid. Okay, so whenever you have a reaction, you'll probably just add two things together in the lab. And then we're going to ask you later, okay, what was the chemical reaction? And what is the solid that you're looking at? Okay, so let's do the second one. Sodium hydroxide and copper chloride.
Right.
So let's switch places.
Who do you want to go with first?
Copper.
All right. So copper hydroxide. Copper is a 2+, hydroxide is a -1, so we're going to need 2 hydroxides.
Okay.
And then we're going to look. Our copper is not in the soluble things up here. No, not in the exceptions. Down at the bottom. Hydroxide ions say that it is insoluble, and it is not one of the exceptions. So that is going to be our solid.
Okay, so that's our precipitate. And now we need to finish out the reactions. So we're going to do NaCl.
Yep.
That is going to be aqueous. And now we need to balance. We've got 2 chlorines over here, so we need to add a 2
Yep.
here, and now a 2 over here. Okay, so this is what a complete chemical equation looks like. You have coefficients. You have in subscripts what's the state of matter, and they're totally balanced.
It looks fabulous.
Okay, water. Aqueous reactions also can form water, but this is normally when you have an acid and a base. So an acid normally starts with an H, and your bases normally end with an OH. So the H and the hydroxide, they are going to combine together to form H2O. So these are pretty easy.
Yeah, so
For
it's
me.
an acid-base reaction, so we're going to get water. Water is going to be a liquid. It's not aqueous. It's not being dissolved in there. It is the water, so it's going to be a liquid. And then your other piece is going to be your aqueous piece, which is going to be sodium bromide. Na is a +1, Br is a -1. Cancel each other out, and we're good. AQ.
Okay. Okay, now the next one, again, we're going to form water because we've got a hydrogen at the beginning and a hydroxide at the end of the other one. So that's an L, not a C, everybody. So we're going to form NaCl, again, water and a salt.
Yay.
Okay, next one. Aqueous reactions that form gases are usually double replacement reactions. So if you're in a lab and you combine two things together and you see smoke or bubbles or things like that, that's going to be an indication that you are forming a gas, right? Okay. So hydrogen, what is that? Iodic acid?
Hydroiodic. Yeah.
Hydroiodic?
Always fun to say.
Yes. So you're going to do a double replacement here. You're going
So
to
H2S. H is a +1, S is a -2, so we're going to have 2 H's for every S. It is going to be the gas.
Okay, and now do the other one.
And LI, +1, -1 cancels, and that one's going to be the aqueous.
Okay, and then balance.
We
Okay,
need 2 H's.
yeah.
That makes 2 I's. And we got our
Okay.
2 LI's.
So how are you going to figure out that it's a gas?
On the gases, we're probably going to tell you it's a gas, and you just have to identify it as putting a G behind it.
And you could also identify one as being aqueous and you know the other one's going to be gas, especially if you saw the reaction and you know they gas forms.
Right. We're hoping we don't actually get that type of gas because that's a bit poisonous.
Yes, it is. Hey, it could be fun. All right. Now we got to deal with ionic equations. So a complete ionic equation, this is a lot of writing, but it shows all of the particles in a solution as they exist. You have to take your compound, break it into its ions, include the oxidation number or the charge. You have to include the coefficient and the states of matter.
Whew.
So I'm really excited about all this writing. I gave you a formula in your notes. It is sodium hydroxide plus copper chloride. It forms sodium chloride and copper hydroxide. So this is a precipitate reaction. You've got your solid at the end.
All right, so solid's going to stay as a solid chunk. You only have to separate out into the ions anything that is aqueous out of anything that's an ionic equation. Because if you separated out everything would cancel when we go to the canceling
Right.
part of this. So we separate out anything into ions that's aqueous. So the first one we're going to do is we're going to have our Na plus, there is a coefficient. That coefficient goes through everything within there. So we're going to have 2 ions of sodium, and we're going to have 2 ions of the hydroxide. Hydroxide is
looking good.
OH minus. They get really kind of long. It might take 2 spaces if you're trying to crunch it in a small spot, but luckily we gave you lots of space here. Mrs. Kelly's showing you now we're on to the second little compound.
We're just going to
We've
keep
got
going.
the copper, which is going to have the 2+ charge, and then the chlorine had a subscript of 2. That subscript of 2 only goes for the chlorine ions, so we have to showcase that there are 2 of them. Now we're going to move to the product side, and
Okay.
we only
I
have
think I
to,
can get
again, separate out
The aqueous.
the aqueous. So we're going to do the 2 sodium ions and the 2 chlorine ions. And we're going to leave together as one chunk anything that is solid, that is liquid, or that is a gas for this complete ionic equations. Anything solid, liquid, or a gas stays as a chunk.
Okay,
No ions
so check all of them. They have a coefficient, they have an oxidation number, they have a state, they have a symbol. We're
Looks
good to
good.
go. This is your complete ionic equation.
It is the longest one. Complete means everything.
Okay, now keep this all in mind. This is going to be hard for us to do. I may go back. Okay. Spectator ions are the ions that do not participate in the reaction. We talked about this in the last section, but again, spectators are just sitting there watching. They're on the sidelines. They're not actually reacting, but they are necessary to be there so that the reaction takes place.
Yes.
Okay. So let's identify the spectator ions in the complete ionic equation.
All right.
And these, again, do not participate in the reaction. So I'm going to go back to the previous slide. You have a space for, are there spectator ions in the equation above? Figure that out.
Okay, so we're
I
going to look
probably
for ions that are ions on both sides, product side and the reactant side. So I see 2 Na pluses
Yeah.
on the left and on the right.
Okay, so
So we're
let's
gonna
see.
cross
I'll
it
write
off.
these down here for your spectators. Okay, and I'll cross it out up here.
All right,
Cross it out up here. The other one,
is 2Cl minus.
mm-hmm.
We got 2Cl minus there and there. So they're ions on both sides. That means that they are just sitting there chilling, watching everything else happen.
Okay, so these are your spectator ions. So you're going to cross them out, and now you're left with this 2OH negative, and then copper 2, and then your solid on the other side. Now this is when we get into our net ionic equation. So, do you think we can remember that?
Yes.
Okay, so we're going to look at the complete ionic equation. You guys have it easy because you're looking right above at what we're looking at. And you're going to cross out the spectator ions like we just did. Only include the ions that participate and write the net ionic equation. So what was our first one?
If you want to go back, we could just do it in another color. You got enough room.
And then I have
Yeah,
to
right
figure
there.
out a different color.
Oh, then don't. Then just write it down in that bottom corner.
Okay.
But not over our faces.
I know.
Or under our faces.
All right. Well.
All right. Oh,
What,
whoa, you're trying to get
I'm gonna figure out the
fancy.
color. All right. We'll do blue.
Okay.
Hopefully it shows up. Okay.
Alright.
So ready? Do we need to put the positive first, or do you care if they put the negative first?
I usually put the positive first.
I do too. We're just kind of nitpicky. If you haven't noticed, chemistry and chemists, we like attention to detail. All
Yeah.
right. Positive would come first. It's only natural. All right.
It's So we write down anything that we haven't canceled out on both sides. So we've got our copper ion, we've got our 2 hydroxide ions, and then what's